Another statistical assumption tells us that our dependent variable should be approximately normally distributed. So if you think back to like intro stats, we know that a normal distribution looks like a bell-shaped curve, where the majority of the values kind of gather around the mean. So we can determine if we have a normal distribution, we can do it both ways. So you can do it visually just by looking at a histogram, or you can do it numerically by comparing measures of central tendency. So again, let's take a look all the way back to intro to stats. We know our mean is a measure of central tendency here, so we know this number represents when we add all of these values together and then divide by how many values we have, which is 20. So adding all these together, dividing by 20, that gives us 2.05. Another measure of central tendency is, think about it, median. So our median is the number that we get when we rank our numbers smallest to largest, and then we find the number that is exactly in the middle. So our median, we can calculate that automatically, is 2. So we're comparing these two numbers, these two measures of central tendency, to ensure that they are consistent, to ensure that our data clusters around this value, which in this case looks to be about 2. So we can say just by numerical approximation that this set of values is approximately normally distributed. Another way we can do that is just by looking at our histogram here. So like I said before, we know that a normally distributed set of data looks like a nice smooth bell-shaped curve with the majority of the data clustering around the mean. And this holds true in this case. If our data were not normally distributed, we might see negative skewing, which would look like really big bars over here and descending into small bars, or positive skewing with big values over here that descend the other way, or there just might not be any pattern at all. So, but that's not true here. So we know with this nice smooth curve that we have a normal bell-shaped curve, and we know numerically that our measures of central tendency align, so we can say with confidence that our dependent variable is approximately normally distributed.